So this core module is the brain of the whole trading system, right? It takes trading data and deal events, then tells the broker what orders to place.
Precisely. And it's crucial for both finding good strategies and executing trades in real time. It's a key communication link.
So the core module isn't just for strategy searching, it also handles live trading. The strategy manager activates a strategy instrument pair.
Correct. Worker apps in the strategy service subscribe to candle events for that specific pair. The core module then acts on these events.
So the core module primarily uses market orders, right? Faster execution, that's the idea.
Exactly. System orders handle the overall logic, and market orders are instantaneous. This is efficient for quick trades.
And the data stream is limited to minute candles? Why that choice?
Minute candles are sufficient for most calculations. Other intervals can be derived from them. Also, many exchanges have limitations on the number of WebSocket connections you can use.
So, the candle record includes all the crucial details like exchange ID, instrument ID, interval, open, close, high, low prices, volume, and open date. It's comprehensive.
Precisely. The data structure ensures we have everything needed for calculations. All these fields are essential for a thorough analysis.
Minute candles are prioritized. Why?
Minute candles are sufficient for most trading strategies. They provide enough detail. Derivations for other intervals are achievable from these. Moreover, broker constraints on WebSocket connections and bandwidth are important factors.
The handler for minute candle events checks for correct context and updates context with new candles, checks system orders, and then calculates signals. Quite a thorough procedure.
Absolutely. This methodical approach guarantees that all relevant factors are considered before generating any trade signals. The system is designed to be efficient in its processing.
Signal calculation is crucial. The signal value field is vital.
Indeed, null indicates calculation failure, often due to missing historical data. This prevents erroneous trades.
If a calculation fails for either open or close signal, the command halts. Why?
To avoid opening or closing a position when there is uncertainty about the signal. A potential error is avoided.
Opening and closing signals both positive result in no action?
Correct. This avoids contradictory signals, ensuring a stable strategy.
The strategy opens a position if the opening signal is true, or closes all open positions if the closing signal is true.
Yes, opening multiple positions can be beneficial in some strategies. This design allows for this.
The signal class defines a signal with an ID, name, and a condition. The condition is key.
Exactly. The condition class, with its code, index, and isGroup flags, represents the hierarchical structure of the signal logic.
The condition class has indicator 1 ID, condition type, and indicator 2 ID. This directly links to indicators.
Correct. This allows for complex comparisons between different indicators.
Signal data links signal and indicator values. Why is indicator 1 used instead of indicator ID?
For flexibility, different candle intervals can use the same indicator for comparison.
Strategy signal param and strategy signal candle store indicator parameters and intervals. This is crucial for precise signal calculations.
Absolutely. They provide the necessary details to accurately calculate the indicator values needed for signal evaluation at different granularities.
Strategy signal candle stores the crucial interval and range for indicator calculations. Candle interval ID, candle from, and candle to are essential.
Precisely. These fields specify the exact candle interval and depth for indicator calculations, allowing for granular analysis.
Strategy signal param contains indicator parameters. Why is this important?
It provides all necessary values for indicator calculation, ensuring accuracy.
The strategy class now includes strategy signal params and strategy signal candles. Why is this design change important?
It bundles the necessary details for signal calculation within the strategy, improving data organization and reducing redundancy.
Repositories for strategy and signal retrieval are added. Why?
Retrieving these entities is crucial for accurate signal calculations. Repositories encapsulate this, improving maintainability.
Strategy context is enriched with strategy and signal information. What does this allow?
Access to these entities is now readily available within the core component, simplifying calculations.
The init context command handler retrieves strategy and signal data. This is crucial for calculations.
Agreed. Retrieving these entities upfront avoids repeated lookups during signal calculations.
What happens if the strategy or signals change after initialization?
The strategy would need restarting. The current implementation assumes these entities are static during a strategy's operation.
Calculate signal command handles signal calculation. What data does it need?
It needs the signal definition, signal object, related indicator data, and historical candle information, readily available in strategy context.
Calculate condition is called within calculate signal command. Why is this function important?
It evaluates the conditions defined for a given signal, ultimately determining if the signal is triggered, true, not triggered, false, or if calculation is currently impossible, null.
The calculated signal data is saved to the database. Why is this important?
This persistence lets the user review and verify the signal calculations, crucial for debugging and strategy validation.
The calculate condition function handles both group and non-group conditions. How does it handle cases where some conditions can't be calculated?
Creates a flag one of child is null. If any child condition evaluates to null, the overall result is null. This is important for robustness.
Calculating non-group conditions requires accessing historical candles. How is this done?
The function retrieves the candle depth from the signal settings and checks conditions against candles from that depth.
The example shows indicator _1 and indicator _2. Are they calculated at the same interval?
No. The example shows different candle intervals for each indicator. This allows for comparisons across different time frames.
Given the example, what is the crucial element to get the correct condition result?
Ensuring that calculations for all relevant candles within the specified ranges are completed successfully is crucial. Any missing or invalid data will result in null or incorrect results.
How does the code ensure each indicator's data is within the defined range for the new candle?
Nested loops iterate through candles within the specified range for each indicator. Data is validated to ensure a complete comparison.
Are these loops computationally expensive?
Potentially, yes. The number of iterations depends on the candle from and candle to values. Efficient calculation of indicator values is essential to mitigate performance issues.
The code iterates through historical candles to evaluate conditions. This example shows comparing indicator values across different time frames.
Correct. It's crucial to check conditions for the specified number of candles before and after the current candle.
If an indicator calculation fails, how does the system respond?
The result for that candle is null, and the overall condition result is potentially null as well due to the nested loops.
What's the significance of the candle from and candle to values?
These values define the range of historical candles to consider. The calculations are performed only within this range.
The example shows different candle from and candle to values for each indicator. Why this difference?
It allows comparisons between indicators calculated at different time frames, enabling more complex strategy logic.
The loops iterate through potential candle combinations. Is this computationally feasible for a large number of historical candles?
Could be computationally expensive. Optimization in the calculate indicator value function is essential for performance. The candle from and candle to settings play a vital role in limiting the calculation range.
How does the code ensure it's checking the correct historical candles for both indicators in calculate not group condition?
The two loops, one for each indicator, ensure the correct historical candle data is used for comparison. It checks each indicator over its specified time frame.
Are these loops handling the potential cases where one indicator may be available, but the other may not within the time frame?
Yes, the code handles cases where one indicator might not be available. The decimal type for indicator values allows for null values. A null value in either indicator will produce a null result for the overall condition check.
The calculate indicator value function calculates an indicator value. How does it handle potential issues with indicator calculations?
It uses a nullable decimal type. If a calculation fails, the result is null. This prevents errors from propagating through the system.
The function relies on Indicator Calculator Manager. What role does this manager play?
Indicator Calculator Manager manages a list of indicator calculators. It's a singleton providing centralized access to calculations.
Is Indicator Calculator Manager necessary for the calculation logic to be stateless?
No, it's not necessary for statelessness. It stores calculated indicator values, making it stateful, which is convenient for calculating conditions needing historical data.
How does Indicator Calculator Manager store historical data needed for indicators?
It uses a history calculator class to store indicator values for specific candle intervals. History calculator provides efficient retrieval of calculated values.
What's the crucial data structure passed to calculate indicator value?
The underscore strategy context. Candles list provides the necessary candle data for the calculation. It allows access to historical candle information.
How does the code ensure the correct candle is used for an indicator calculation given a specific candleback number?
The code accesses the relevant candle from the underscore strategy context. Candles list based on the specified candleback number.
Are there potential issues with large numbers of candles in underscore strategy context? Candles?
Potentially, yes. Efficient data structures and optimized calculation methods are crucial to mitigate issues with high numbers of candles.
What's the advantage of using a separate manager class like Indicator Calculator Manager?
It centralizes indicator calculations, allowing reuse and potentially improved performance. It promotes better organization and maintainability.
Indicator Calculator Manager manages calculators. Why is it a singleton?
Centralized access and management of indicator calculators are key benefits. A singleton ensures only one instance exists.
How does History Calculator handle calculations needing multiple candles?
It stores calculated values for specific candle intervals, allowing efficient retrieval for conditions referencing back candles.
The init method in Indicator Calculator Manager is recursive. Why is recursion needed?
Recursion handles the hierarchical structure of conditions. Each child condition in a condition group requires its own indicator calculator.
How does getCalculator determine the correct indicator calculator?
It retrieves the calculator based on the indicator ID from the condition and whether it's the first or second indicator in the comparison.
How does the code ensure the candleback number is correctly used in History Calculator?
History Calculator accesses candles from the provided list based on candleback number.
getCalculator retrieves an indicator calculator. How does it ensure the correct calculator is found?
It looks up the calculator by indicator ID from the condition and whether it's the first or second indicator. It uses the underscore service provider to get the keyed service.
What's the purpose of strategy signal candle in getCalculator?
Strategy signal candle provides parameters like candle2, candle interval, and candle interval, essential for specifying the calculation window and interval for the indicator.
How is max candles count calculated in the History Calculator object creation?
Max candles count is derived from candleparam.candle2 plus 1. This defines the number of candles to consider for the calculation.
What are the implications of not having a candleparam for a given signal ID or condition code?
If no matching strategy signal candle is found, it implies a missing configuration for that indicator and could lead to errors.
Given the getCalculator function depends on underscore service provider, how does the code ensure underscore service provider is initialized?
Underscore service provider initialization is handled elsewhere, likely in application startup or dependency injection.
Add indicators dynamically adds indicator calculators. How does it ensure calculators implement iIndicator calculator?
It uses reflection to find all classes in the current assembly that implement iIndicator calculator. This ensures all relevant calculators are registered.
The calculate method in History Calculator takes a list of candles. How does it find the correct candle?
It filters the list using candles. First, C equals C, interval equals candle interval. This finds the candle matching the expected interval.
Neat calculation checks for changes. What does this method check?
Neat calculation verifies if the new candle's data differs from the cache data. If it does, a recalculation is necessary.
Calculate calls another calculate method on the calculator object. What does this imply?
This signifies a separate calculation logic within the specific indicator calculator, potentially using the new candle.
Add indicators adds calculators using add keyed transient. Why keyed?
Keyed registration allows accessing specific calculator types by their ID. This provides a way to get the correct calculator later.
What crucial role does indicator IDs play in this design?
Indicator IDs acts as a key, identifying the specific type of indicator calculator, ensuring correct registration and retrieval.
Add indicators uses appDomain.currentDomain.getAssemblies. Why this method?
Defines all assemblies in the current application domain. This is necessary for dynamically discovering and loading indicator calculators that might reside in separate assemblies.
The ATR calculation uses a formula based on the true range. How is true range calculated?
True range is the maximum of 3 values: high minus low, absolute value of high minus previous close, and absolute value of low minus previous close.
The average calculator class is abstract. Why?
It's abstract to provide a common framework for calculating average indicators. Specific indicators like ATR inherit from it.
The calculate method in average calculator takes a calculate value function. What's the purpose of this function?
This function encapsulates the calculation logic specific to the inheriting indicator. It's passed in to allow flexibility in the core calculation method.
How does average calculator ensure it only considers the required number of candles?
It maintains a sorted list of candles and removes the oldest when the list exceeds the maximum count, ensuring the right number is always used in calculations.
ATR indicator calculator inherits from average calculator. What is its role?
It implements the specific ATR calculation logic by providing the calculate value function that calculates true range for each candle in the sorted list and averages them.
Given ATR indicator calculator inherits from average calculator, how does it handle initialization through iService provider?
It inherits a init from average calculator, which is called using iService provider, ensuring proper setup of the underscore max candles count value from the parameters.
ATR indicator calculator. Calculate method calls base calculate. What does this imply about its relationship to average calculator?
ATR indicator calculator leverages the core logic of average calculator for managing the list of candles. It then calculates ATR using its specific calculate value function.
In calculate value, the code iterates through last candles starting from index 1. Why not 0?
Skipping index 0 avoids referencing the current candle in the calculation of the previous close price for true range calculation.
What does calculate value calculate for each candle?
It computes the true range for each candle and accumulates the results.
How is the final ATR value calculated?
The sum of true ranges is divided by the number of candles to get the average true range.
Open position command handler calls generate position command. Why a separate command?
Separating position generation into a command allows for potential integration with capital management logic in the future.
Generate position command checks for existing active positions. What if multiple positions are found for a single strategy and instrument?
If multiple positions exist, generate position command will return null, preventing the creation of additional positions.
Generate position command calculates position count. What formula is used?
Position count is calculated by dividing the product of position balance coef and the balance by the current price.
If a position is open and risk control triggers a close signal, how are auxiliary orders handled?
All auxiliary orders associated with the position must be canceled.
What if a buy order is placed and the broker doesn't confirm its status?
A separate mechanism is needed to handle such scenarios. A status check loop is not appropriate.
Why was a status-based position processing approach abandoned?
Status-based processing became overly complex as the system evolved, making the logic and transitions hard to manage.
How does the light state machine approach solve the complexity issue?
It executes each step immediately when an event arrives. This avoids a complex state transition system.
How does the light state machine prevent excessive parallel processing?
The architecture limits each pod to one strategy instrument pair, ensuring only one position is processed at a time.
What if two events arrive simultaneously for a single entity.
Blocking the entire bot process for all threads for a single event ensures only one event is processed at a time.
Is there a risk of the pod missing events?
Potentially, but the system is not designed for high-frequency trading, so this is considered acceptable.
Multiple orders for a single position could lead to simultaneous status change events. How does the system handle this?
The system blocks all threads when an event arrives. This ensures only one event is processed at a time.
What's the risk of this blocking approach?
The pod might not process all events in the queue.
Given the system's design isn't for high-frequency trading, is this a concern?
It's considered acceptable because of the low expected event volume.
How does the system determine which event to process next?
It's a first-come, first-served basis. The process handles the first event that arrives, then moves to the next, and so on.
What is the role of the process map in this system?
The process map defines the workflow steps. Each node in the map corresponds to an action or state.
How is the process map used in the event handling workflow?
The system moves along the process map according to the current node and events.
If the process map is in the code, how is consistency maintained across subsystems?
The code for the process map is shared between subsystems. This guarantees consistency.
How does the system know the current state of the entity?
The calling library provides a getCurrentNodeID async method, which returns the entity's current state.
What is the role of moveEntity command?
It drives the entity through the process map by sending instructions for each step.
The moveAsync function handles an event. How does it find the next step in the map?
It uses the current node and the event to determine the next step.
What is the result type of moveAsync?
It returns a Boolean value. True if the entity completes its workflow. False otherwise.
How does the system ensure only one event is processed at a time?
It uses the lockAsync function to block the process for other threads.
So, the moveAsync function, after handling an event, iterates through nodes. How does it determine the next node's ID?
It uses the getNextNodeID function, which takes the current node and the event as input.
If getNextNodeID finds no next node, what happens?
The function returns null, signifying the end of the workflow for the entity.
How does the handleNode function decide what to do with the next node?
It checks the node type using a switch statement. If the node is an act node, it calls the corresponding action. If it's a waiting node, it continues the loop. For other types, it handles them accordingly.
What happens if handleNode encounters an unknown node type?
It throws an exception.
HandleEvent looks for a trigger node. What criteria does it use?
It searches for nodes where the event ID matches and the node's code is greater than the current node's code.
If no trigger is found, what happens?
It returns null. If the current node ID is null and an event ID is provided, it returns the first node matching the event ID.
Okay, so handleNode gets a node ID. How does it determine the next node if the previous node's result doesn't give a next node ID?
It looks for the next node with a higher code than the current node.
How does the makeAction function work?
It retrieves the iProcessAct instance using the _processAct factory, and then calls its make method with the entity ID and the node's magic string.
What happens if makeAction encounters an unknown iProcessAct?
It throws an exception.
What does the handleNode function do with other node types besides act?
For waiting, it returns false for move and null for next node ID. For trigger and description nodes it does similar, returning appropriate values.
So, the code is handling different types of nodes using a switch statement. How is consistency of the node types maintained?
The node types are defined in an enum and used consistently in the process map code. This ensures consistency throughout the system.
So, the stop and alert state seems a bit unusual. Why is it a separate state for failed asset sales?
It's a safeguard. Retrying might not yield a better price. An alert is a more conservative approach.
How does the system prevent a runaway growth of open positions?
It uses a queue to track active positions and checks this queue to ensure open positions are within acceptable limits. Also, the system has a limit on how many positions can be opened concurrently.
So, the system keeps a separate table for active positions. How does this table prevent an unlimited growth of open positions?
The generate position command handler first checks if any active positions already exist. If there are, a new position isn't created. This ensures a limit on the concurrent positions.
Why is generating a new position separated into a separate command?
Separating it allows for the integration of a capital management block later. Capital management logic can be incorporated into the position generation step.
What happens if the generate position command returns null?
If it returns null, it means the position limit has been reached. No new position is created, and the handler returns false.
Why is the position generation process separated into a separate command?
Separating it allows later integration of capital management. This command can then incorporate capital management logic to calculate the appropriate amount of the financial instrument to buy.
How is the position count calculated?
It's calculated by multiplying a coefficient by the current balance and then dividing by the current price. This result is rounded to the nearest whole number.
What are goods in the context of a financial instrument?
Goods are components of a financial instrument. A typical example is a stock and its associated currency. For example, POWI_USD. POWI is the stock, USD is the currency. Consider cryptocurrency like Ethereum. The associated currency decimals are important.
Why is rounding important for the position count?
Rounding ensures the correct whole unit is used for transactions. You can't always buy fractions of currency or units of assets.
The code snippet shows generate position command handling. Why is current quote balance retrieved?
It fetches the balance for the specific instrument, exchange, and strategy. This is crucial to see if there are sufficient funds to open a new position.
What's the role of position balance coef?
This coefficient determines the portion of the available balance to allocate for a new position.
How is the position count calculated?
Dividing the total position amount by the current price of the instrument gives the position count. This is rounded to the nearest whole number to ensure whole units are traded.
Why is handle final order status command a single command?
It efficiently manages order status updates from the broker, parsing the status and triggering the correct position processing events.
What are the different position order type values?
Open, auxiliary, and close. These types classify system orders within a position for easier management.
Why is system order important?
System order tracks system-level actions for positions, including orders like stop loss or take profit. This provides detailed control.
Why is the reaction to position movement only triggered by changes in open or close system orders?
Auxiliary system orders are created only according to risk control settings, affecting only position closing.
What does handle final order status command do?
It processes order status updates from the broker, saves the new status, and triggers position processing events based on the status and position type.
Why is close positions command necessary?
It triggers the closing process for all active positions when needed. This is used when a signal to close all positions is generated.
What are the different types of system order?
Stop loss, take profit, and trailing stop. These are crucial for setting price limits for position management.
Can you elaborate on how handle final order status command triggers position movement?
It determines the appropriate event based on the order's position type and status, e.g., open order done, close order error. Then, it initiates the position processing movement using the move entity command.
Close positions command triggers closing of all active positions. Why is this needed?
It's essential for closing all open positions when a signal to close all is received.
What's the role of the risk control entity?
It defines the parameters for system orders like stop loss, take profit, and trailing stop, which manage position risks.
How do stop loss orders function?
They close a position if the asset price falls below a predefined threshold, a percentage below the opening price.
How do check system orders command handlers function?
They retrieve active positions and associated system orders. Then, they check conditions based on the order type.
Explain trailing stop orders.
Trailing stops have 3 borders. A profit border similar to take profit, but based on a moving target price. A stop border for closing below the moving target. A decision border triggers target price adjustments based on a signal.
How is the target price calculated in a trailing stop?
The target price adjusts based on the border change coef and the number of border changes, making the profit and stop borders progressively closer.
How does the check system orders command handler process orders?
It gathers active positions and their associated system orders. Then, it checks conditions based on order type, triggering actions like stop loss, take profit, or trailing stop adjustments.
What's the core logic behind stop-loss_update price?
It checks if the current price drops below a calculated stop-loss price. If so, it closes the associated position.
How do take-profit_update price and stop-loss_update price differ?
They differ only in the comparison sign used to check the price against the calculated stop-loss or take-profit price.
How does the trailing_update price function work compared to the others?
Trailing_update price adjusts the trailing stop border based on price movement and the number of adjustments. It's more dynamic.
Can you explain the role of change count in these functions?
Changed count affects the calculation of the trailing stop border, making it more responsive and dynamic to price changes.
What is the impact of the trailing border change coef on the trailing profit border coef?
It progressively reduces trailing profit border coef with each price change adjustment, narrowing the trailing stop's profit border range.
How does this update impact the trailing stop order's behavior?
By gradually reducing the margin for profit, a trailing stop makes a stop-loss order more dynamic and robust.
So, the trailing stop order dynamically adjusts its profit threshold. How does this responsiveness work practically?
It progressively tightens the profit margin with each price change adjustment. Each time the target price changes, the coefficient decreases.
How does that translate into a numeric example?
If change count is 0, the full 10% trailing profit border coef is applied. For one shift, it reduces to 9.5%. This continues.
Why is this important for risk management?
This dynamic adjustment prevents excessive profit seeking, protecting the position from substantial price swings.
So, check border checks if the price crosses a threshold. What happens if it does?
If the price crosses the threshold, a signal is checked. The signal's outcome determines if the target price is adjusted.
What's the purpose of the trailing decision coef?
It determines the trigger price for adjusting the trailing stop's target price.
How does the value of decision price relate to trailing decision coef?
Decision price is calculated by multiplying the current price by 1 plus the coefficient.
How is the decision to adjust the target price made?
The check border function checks for price crossing the decision price and then checks a signal. The signal's result determines the adjustment.
How are trailing profit border coef and trailing border change coef used in conjunction?
Trailing border change coef reduces trailing profit border coef with each adjustment, narrowing the trailing stop's profit margin.
How does trailing border change coef affect the stop-loss border?
It has no direct effect on the stop-loss border. It only affects the profit border.
Why is the calculation of trailing border change coef based on a power function?
The power function ensures the trailing stop profit margin narrows progressively with each adjustment.
How does this progressive narrowing relate to risk management?
Progressive narrowing limits potential losses and protects against significant adverse price movements.
This code adds acts to the service collection. How does this help the system?
It allows the system to dynamically find and use the needed actions during position processing.
What if the needed action isn't found?
An exception is raised, indicating a missing action.
How does the add-keyed transient method help in this context?
It establishes a mapping between action identifiers and their implementations.
What is the purpose of ACT IDs?
ACT IDs acts as a unique identifier for each type of action.
How is this identifier used in the code?
It's used to retrieve the correct action implementation from the service collection.
Why are the actions added using add-keyed transient?
Transient registration means an instance is created for each request.
What happens if there are multiple actions that have the same identifier?
The system will pick one and use it based on the registration order.
How does this approach help with scalability?
It helps decouple the actions from the core logic. This makes it easier to add, update, or remove actions without changing the main logic.
Why is the open system order retrieved before calculating the average price?
Ensuring the opening order exists before calculation. An error is appropriate if it doesn't.
What's the purpose of the average price function?
It calculates the average price from the deals associated with an order.
How does the average price calculation handle potential null or empty deal lists?
Returns 0 if no deals are found.
What's the significance of the risk control .create protect order less check in Create Auxiliary Orders Act?
It conditionally creates a stop-loss order based on risk control settings.
How is the Create System Order command utilized in Create Auxiliary Orders Act?
It sends a command to create a new system order, specifically a stop-loss order in this case.
In Create Close Order Act, why is the calculation of the balance using a sum of deals counts also considered the sign of the order?
Order side, buy or sell, dictates the sign of deal count in the balance calculation. This accurately reflects the net asset position.
How does the Create Close Order Act function deal with orders that haven't been fully executed or have errors?
It only calculates the balance of fully executed trades. Orders not fully executed or having errors are not considered.
What is the main purpose of Create Close Order Act?
It handles the creation of a market sell order for closing a position and selling all assets.
Why is Create Close Order Act different from the earlier Create Auxiliary Orders Act in creating closing orders?
Create Close Order Act handles closing all assets associated with a position, while Create Auxiliary Orders Act creates auxiliary orders, like stop-loss or take-profit orders, which aid in managing positions.
The process bot Lite describes the position lifecycle. How is this crucial to the system's profitability?
The lifecycle defines how a position is handled, from creation to closure, influencing whether the strategy yields a profit.
How does changing the calculation logic affect the system's success?
Changes in calculation logic directly impact the signals generated, which in turn affect trading decisions and potential profits.
Adding indicators also plays a key role. Why?
More indicators lead to more nuanced signal generation, increasing the system's potential for profit.
Changing the process map is important too. Why is that?
Modifications to the process map alter the position lifecycle's handling steps, thus impacting the overall profitability.
What are the most important factors impacting the system's efficacy?
Calculation logic, indicators, and the process map are the most impactful elements in determining the success of the system.
Why is the init method used in Indicator Calculator Manager instead of a constructor?
Indicator parameters might not be available until initialization, and iService Provider is used for instantiation.
How does Generate Calculators handle nested conditions and signals?
It recursively initializes generators for each child condition in a group.
What is the purpose of History Calculator?
It stores calculated indicator values for a given look-back period.
How does the Calculate function in History Calculator handle retrieving the appropriate candle for calculation?
It finds the candle with the required interval from the provided list.
What does the Need Calculation check do in Calculate?
It verifies if the relevant candle has changed, triggering recalculation if needed.
How is the result of the calculation stored in History Calculator?
It stores the calculated value in a field and then returns it on request.
Why is Indicator Calculator Manager a singleton?
To ensure only one instance of the Calculator Manager exists to avoid redundant calculations.
What is the key functionality of the Average Calculator Abstract class?
It provides a common implementation for calculating average indicators.
In the ATR Indicator Calculator, how is the ATR calculated?
It calculates the true range for each candle, sums them, and divides by the look-back period.
What does the Calculate Value function in Average Calculator do?
It calculates the average value based on a function passed to it.
What is the order side enum used for?
It specifies the direction of an order, buy or sell.
Why is order side considered in Create Close Order Act?
To determine the correct sign for the asset balance calculation.
What is the role of the Handle Final Order Status command?
It parses broker order status changes and updates the system order status, triggering position processing events.
The Open Position command handler handles position creation. What's the purpose of the Generate Position command?
It's a separate command to generate a new position, allowing for later use of a capital management block.
How does Generate Position command handle the number of open positions?
It checks for existing active positions. If there are any, it returns null, preventing the creation of a new one.
What role does the position balance coef play in strategy settings?
It defines the proportion of the current balance used to open a new position.
How are quantities handled in generate position command?
It calculates the position quantity by dividing the portion of the balance by the current price.
What improvements could be made to the position quantity calculation?
Consider adding decimal support to the financial instrument model and potentially lots for more precise order sizes.
How does generate position command handle broker restrictions?
It doesn't explicitly handle broker restrictions, which would need additional checks.
The handle final order status command handles order statuses. Why is this important?
This updates the system order status, triggering position movement based on the order completion.
What types of system orders are handled in check system orders command?
Stop loss, take profit, and trailing stop orders are handled.
How are stop loss underscore update price and take profit underscore update price different?
They differ in the comparison sign used to determine whether the price has reached the defined threshold.
How does check profit border handle the narrowing of the trailing stop loss border?
It uses the trailing border change coef, which diminishes with each price change affecting the profit border calculation.
What's the purpose of the check border function?
It determines if the asset price has crossed a predefined border, initiating a potential target price change.
Why are process acts essential to the position lifecycle?
They define the actions performed at each step of the process map, governing how a position is managed.
How does Create Auxiliary Orders Act determine the target price?
It calculates the average price of all deals within the opening order.
What does Create Close Order Act do regarding previously purchased assets?
It calculates the total asset volume based on all executed trades and potentially places a sell order to close the position.
How does Create Close Order Act handle order sides?
It uses the order side to determine the correct sign when calculating the asset balance to correctly determine the appropriate direction for the sale.
What is the role of the ICOR Act interface?
It's an interface for process acts, defining a static Act ID field for each action.
How does the system add process acts to iService collection?
It finds all classes implementing ICOR Act, gets their Act ID, and adds them to the collection with the Act ID as the key.
What is the purpose of the Create Close Order Act action?
It creates a closing order to sell assets acquired during a position.
How does Create Close Order Act handle previously purchased assets?
It calculates the total volume of assets based on executed trades and potentially places a sell order.
Why is the order side important in Create Close Order Act?
It determines the correct sign for the asset balance, essential for calculating the appropriate sale volume.
What are the different types of system orders?
Stop loss, take profit, and trailing stop orders.
What is the logic behind the stop loss order?
It closes a position if the current price falls below the price at order creation minus a specified percentage.
How is the target price determined in Create Auxiliary Orders Act?
It's the average price of all deals in the opening order.
What are the advantages of using a light state machine in this context?
It allows for immediate event processing without needing background jobs, suitable for relatively infrequent events.
What are the limitations of the light state machine?
Potential backlog of events if processing becomes slow.
What are the potential problems with handling multiple events simultaneously in a light state machine?
It violates the principle of a state machine where an entity can be in only one state at a time, potentially causing conflicts.
How does the system ensure that only one event is processed at a time?
It uses a semaphore slim to block other threads, ensuring exclusive access to the processing of events.
How is the lock async function used?
It is used to protect the state machine's processing steps, ensuring only one event is handled at a time.
How does the handle event function handle the first entry?
If the entity is new, it searches for the first node in the process map matching the event.
How does the handle event function handle subsequent entries?
It searches for the trigger node with an event ID higher than the current node's code.